Hey there, hi there, ho there. Welcome to Geology 101. My name is Professor Kovac. I will be your captain on this guide of Earth. So let's jump into it. This is Unit 1. In this unit, we're going to be talking about geology and Earth's formation. The lectures for every unit will be broken up into a series of videos, anywhere from a few minutes up to 15 minutes, kind of chunking out the lecture. As you look at the lecture material that's provided to you in Canvas, this material is either in kind of slide form or lecture note form. Follow along if you would like, not necessary, but I think the biggest thing with these lectures is please watch and listen. Watch and listen. Don't just listen and have it in the background. Don't just watch and have it on mute. Do both. I know it's not the most engaging thing. However, you will learn much more if you're both watching and listening. Because I do post some questions, some things for you to think about, and some things for you to ponder. And a lot of times I will kind of point out things on the screen, different diagrams and images to help you with whatever I'm asking you to kind of learn. So please pay attention, and you'll do just fine. Let's jump into this. So the first section in this first unit is just geology as a science. What is geology? This is a geology class. You ever sit back and think, well, what the heck is this stuff? Well, simply put, geology is the study of Earth through the past 4.5 billion years. That's how old the Earth is, 4.5 billion years. This class is specific to a branch of geology called physical geology. There's a bunch of different types of geologies. Environmental geology, historical geology. This is physical geology. The basis of it all, in which we are trying to gain an understanding of Earth processes and materials. So how the Earth operates, how volcanoes work, how earthquakes occur, and the materials that make up the Earth, minerals, rocks, etc. Now, geology, the common misconception, oh, you study rocks and stuff. Yeah, rocks and stuff. But in that and stuff is a lot of other things. Geology is a profession that's needed everywhere, not only on Earth, as it turns out, but also in space. So, again, the common idea, geologists, oh, you study volcanoes, yeah. But we also need geologists in Antarctica. We also need geologists working with construction crews and looking at natural disasters and looking at infrastructure and how it's impacted. We need geologists in the ocean, under the water. We even need geologists in space. There is some understanding we can gain from material from the moon. Planetary geology is a whole other branch of geology, looking at the geology of things in outer space, in an attempt to try and kind of, explain Earth in itself. It's deep. It's kind of deep, I know. So why do we study this stuff? Why did anybody say, you know what, I want to be a geologist? So why at the root of it, why do people study geology? It's to understand and attempt to fix society's most important problems. Energy, water, mineral resources. We live on a finite planet, meaning there's only so much stuff. So as we're taking that material out of the ground, as we're mining material out of the ground, as we're mining iron to make steel so we can make buildings and cars, there's only so much of that stuff. As we're mining out aluminum ore from the ground to make, my coffee mug, there's only so much of that stuff in the Earth. Fresh water as well. Most of us live in the desert, in the Phoenix metro area here. And this city is growing. Well, there's only so much water. Water is a limited resource. At some point, there's going to be more demand than water available in the Phoenix area. Same with energy, electricity generation. So these are all things to think about. With the climate changing, geologists are helping out with that as well. Natural hazards, as the population of the Earth grows, we are moving to places maybe we shouldn't. We're creeping into areas that maybe have more landslides. We're moving closer to volcanoes. We're gaining population. San Francisco and Los Angeles are growing in population, and they're prone to earthquakes. We're moving into areas that are prone to flooding because the land is cheaper. Geologists need to make sense of all that and need to be able to warn people, hey, you got to watch out for this stuff. when it comes down to it, Earth is our home planet, and we depend on Earth for everything. If it's not mined, if it's not grown, it's mined. Look at everything that's sitting around you right now, wherever you're at. If it's not grown, for instance, cotton fibers for my shirt or the trees that made this paper, if it's not grown, then it's mined. All that material's got to come out of the ground. My coffee cup, that aluminum's got to come from somewhere. The glass on my iPhone here, that glass, that material of that, it's got to come from somewhere. So if it's not grown, it's mined. And once we use up the stuff on Earth, that's it. Some stuff will last a long time. Some we don't have a lot of. So on that same note, limited resources require knowledge and thoughtful management. As the population of Earth grows, we're going to be using more material faster. Have we thought about that? Have we calculated that into our outlook? But the physical processes and the chemical processes that occur on Earth really affects everyone. And geology is not just necessarily looking at just the Earth itself, but the interaction of Earth with humans, with the atmosphere, with a lot of different things. So we have to appreciate our role in geologic change. I'm not talking just about climate change. We're also doing things to affect the Earth as well. We're doing things to affect the atmosphere. We're doing things to affect the ocean. Most of that in a very, very, very negative way. And we have to understand that and not hide from it, but say, you know what? Yeah, we've been doing a lot of bad things. How do we fix it? This is a plaque that's located in Iceland. Iceland, a little island between Greenland and the United Kingdom. Greenland's ice, Iceland's green-ish. So that's kind of a little funny thing about Iceland. But in any case, the people of Iceland put this at a foot of a glacier, or former glacier. Ok is the name of that glacier. So in Iceland, Ok is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all of the glaciers on Iceland are expected to follow the same path. This monument is to acknowledge that we know what is happening, climate change, geologic change, and what needs to be done. Only you know if we did it. August 2019. And this is discussing how much carbon dioxide is in the air, one of the main big two gas drivers of climate change. So, we have to understand that we are affecting the planet. We're doing it. And it's kind of bad news. So how do we fix that? That's where understanding a little bit of geology comes into play. Just one little additional thing I usually like to throw out right away, because the word theory gets used in science a lot. We will encounter that in this unit and next unit as we talk about the theory of plate tectonics. More on that later. And we also talk about the formation of the solar system. So in any case, this word theory gets thrown out a lot, and I want to talk about it because our understanding of the word theory is wrong. How in the United States people use the word theory is vastly incorrect. So if someone were to say, oh, I'm the most handsome man in the whole wide world, someone would be like, oh, that's just your theory. Meaning, oh, that's just your guess, that's your opinion. I think tacos are the best food. They are. I think tacos are the best food. Oh, that's your theory. That's your guess. That's your opinion. That's how we use that word. That's not how that word is applied in science. All right. So get that out of your brain. All right. So what is a theory? So a theory in science is the highest level of knowing. So when you're guessing an opinion, that's the lowest level of knowing. That's no knowing whatsoever. That's just you saying something. But it's almost the reverse of that. In science, a theory is the highest level of knowing. A theory is something that's testable in science. Those tests produce the same repeated conclusions over and over again. It's never been proven false. That's different than it being true. It's never been proven false, and it's widely accepted. So, the Big Bang Theory. Oh, that's just a theory. That's just their guess on how the universe was created. No. At the highest level of knowing, we can run tests for it. Those tests have repeatedly given us the same results, that the universe formed from some sort of cosmic explosion and expansion. The Big Bang Theory has never been proven false. Again, it's different than it being true. It's never been proven. Well, that's just their guess. No, not their guess. It's never been proven false. Well, that's their opinion. No, it's not their opinion. It's testable. It's repeatable. Here's the data. And it's widely accepted among the scientific community. Just because you don't accept something scientific, look what the situation going on currently in 2021 with the vaccine and how silly that might seem to some of you. But just because you don't believe in something doesn't necessarily mean it's wrong. You can be wrong. In fact, you're probably wrong most of the time. I'm wrong most of the time. But it's how we learn from that. So never been proven false like the Big Bang Theory. But with new information, new data, we might change our understanding of how the universe was created. No one says it's correct. It's just this is the information we have. This is, every time we look at this information, it gives us the same data and results. So never been proven false. It's different from it being true. So that's what a theory is, the highest level of knowing in science. We'll be talking about the nebular theory, plate tectonic theory. Hell, gravity is a theory. The theory of evolution. Oh, that's just their guess. No, it's not just their guess. Highest level of knowing. Testable, repeatable, never been proven false. So please, please, please be careful with that word theory is what I'm saying. So we'll pause here. When we come back, we'll talk just briefly about the history of geology, some of the names, some of the big names over the past centuries to get us to where we are today. I'll see you back here in just a minute.